All right, Mavericks and Explorers, let's see how well we did with today's derivative practice. So for the function y equals e to the x plus cosine of x plus the sine of x, if I'm going to take the derivative, I need to take the derivative of the first term, plus I'm going to take the derivative of the second term, plus I'm going to take the derivative of the third term. That's that sum rule. Derivative of e to the x is e to the x. Derivative of cosine of x is negative sine of x. And the derivative of the sine of x is the cosine of x. So that's what you should have for problem number 1. Okay, problem number 2. We have g of x equals e to the x cosine of x. Now I know I didn't write it in the problem, but this is actually a multiplication problem. Since it's a multiplication problem, we need the product rule. What does the product rule tell us to do? Product rule says if I'm going to take the derivative of a multiplication problem, you take the derivative of the first part, so the derivative of e to the x, times leave the second part alone, plus leave the first part alone, times the derivative of the second part. When I do that, I still have work to do back here. Derivative of e to the x is e to the x times cosine, plus e to the x, derivative of cosine is negative sine of x. You could stop there. You could also write it positive e to the x times negative sine of x is negative e to the x sine of x. Another way that you might see it is since we have e to the x showing up in both terms, you factor out the e to the x to get e to the x parentheses cosine of x minus sine of x. Any of these 1, 2, 3 answers are all perfectly acceptable. Let's look at problem number 3. Problem number 3 is h of t is the cosine of e to the t. I have cosine of an angle, but that angle is a function in and of itself. This is the chain rule. Since it's a chain rule, I need to identify the baby. This is the baby function. The mama is the outside function, so the mama is the cosine. So when I find h prime of t using the chain rule, we take the derivative of the mama with the baby left alone, so it's going to be negative sine e to the t times the derivative of the baby. And what's the derivative of the baby? Well, that's just going to be e to the t. So negative sine e to the t times e to the t power. That's your derivative. Another way you might see it is negative e to the t times the sine of e to the t. You could leave it this way, you could leave it that way. That's all perfectly acceptable. That's your chain rule. All right, problem number 4. We have j of x equals e to the x over cosine of x. Okay, that's going to be the quotient rule. Everybody sing it with me, please, on the count of 3. 1, 2, 3. Low d high, high d low, low, low. So, if I'm going to do my quotient rule, j prime of x, I take low, which is the cosine, times the derivative of the high, derivative of e to the x minus high, that's my e to the x, times derivative of the low, derivative of cosine is negative sine of x over low, low, cosine of x, the whole thing squared. A little bit of cleaning up I could do here. We've got cosine of x times e to the x. Negative e to the x times negative sine of x is positive e to the x sine of x over cosine of x, the whole thing squared. You could stop there. That is perfectly acceptable. You could go further in the numerator. When I look at those two terms, I have e to the x as a common factor. When I take that out, it gives me cosine of x plus sine of x over cosine of x, the whole thing squared. You could stop here, here, or here. Any of those 3 places, all those answers are perfectly acceptable. do not, repeat, do not cancel out the cosine of x up here with a cosine of x down here. That cosine and sine are connected to one another, so they're not going to cancel out unless you can get rid of both of them. All right, let's move on to problem number 5. When we look at problem number 5, we have L of x equals e to the x over cosine of x, the whole thing squared. I think pretty clearly we can all see that we're going to have a quotient rule happening inside of here. But actually, if we pay attention, that e to the x over cosine of x is actually the baby. The mama is x squared. And so when I take the derivative, it's going to be 2 times, leave the baby alone, e to the x cosine of x to the 1 less power times the derivative of your baby. And the baby is e to the x over cosine of x. I know we've talked about this notation a lot the past couple of days, but all we did is you took the derivative of x squared, right, because that's your mama. You bring the power down, you reduce the power by 1, and then you multiply by the derivative of the baby. So how am I going to take the derivative of the baby? Well, that's where I need my quotient rule. Again, low-de high, high-de low, ho-ho. So low is cosine of x, d high, e to the x, minus, now you leave the top alone, times the derivative of the bottom, over the bottom squared. You can go further if you'd like to. 2e to the x over cosine of x, parentheses, cosine x, e to the x. Negative e to the x times negative sine of x is positive e to the x sine of x over cosine of x, the whole thing squared. Again, you want to go further, that's great. You might consider leaving the first one alone, and in the numerator, in that second fraction, factor out the e to the x again, cosine of x plus sine of x over cosine of x, the whole thing squared. Stop here, stop here, stop there. They're all algebraically equivalent. I'll take any of them, but you also need to be prepared that any of these might show up as the multiple choice answer on a test. All right, let's look at our last one, problem number 6. Problem number 6, I have e to the x times cosine squared of x. Pretty sure we've talked about this, but that cosine squared is the same thing as saying cosine of x, the whole thing squared. And my advice all the time, don't work with cosine squared. It's sometimes confusing. Rewrite it as cosine of x, the whole thing squared. Now let me see, what do we have? I see multiplication. We're going to need a product rule. I see cosine of x being raised to a power. We're going to have a quotient rule. Which one comes first? It's going to be the product rule. So when I take the derivative, okay, the derivative of e to the x cosine squared of x is you take the derivative of the first, which is e to the x, times you leave the second one alone, plus leave the first one alone, times the derivative. I'm going to write dx cosine of x, the whole thing squared. Because that's sort of a complex function, there's a lot of work going on there, I just wanted to stop and write derivative of that. As a grader, I can see that you clearly understand the product rule is needed to solve this problem. And if you make a mistake after this point, I can at least say, yep, they understand the product rule, they made it up to here, and maybe they made a mistake going past this. So let's finish this up. We have e to the x times cosine of x, the whole thing squared, plus e to the x times derivative cosine of x, the whole thing squared. Cosine of x is the baby. The mama is big X squared. So I bring the power down. Cosine of x to the 1 power times the derivative of the baby. Okay, the derivative of the baby is negative sine of x. You could stop there. you could go further and make it e to the x cosine of x, the whole thing squared. E to the x times 2 is 2e to the x times cosine times a negative sign. What I'm going to do is I'm going to change that positive in front to a negative. You can stop there. That's great. You might look at this term and this term over here looking for a common factor. I see that they both have an e to the x. I see that they both have cosine of x. So I'm going to choose to factor those out. If I factor out e to the x and I factor out a cosine of x, I'm just left with cosine of x minus, over here I factor out e to the x, that leaves me 2. I factor out cosine of x, it just leaves me with the sine of x. And again, any one of the 1, 2, 3, any one of those three perfectly acceptable answers. If you were able to come up, get correct derivatives for 4 out of the 6, you should be feeling pretty good about your calculus skills, especially so early in the course. If you weren't able to get 4 out of the 6, when I come back from Massachusetts, we're going to want to spend some time together, especially looking at these tricky problems. But it's all going to be good.